The deck of a railway bridge is typically built of wood timbers called bridge ties. They're bolted to steel support beams, located on concrete piers over the water or gully below. The rails on which the train travels are bolted to the wooden ties. Wood absorbs the noise and vibration of the passing train. The load the railway bridge will carry determines the size of its ties. To calculate the load, engineers factor in the number of tracks, volume of traffic, weight of the transported cargo, and whether the bridge is straight or curved. A curve will put additional stress on the structure. The wood of choice is oak because it's hard and strong. When the logs arrive at the sawmill, they come face to face with a menacing-looking device called a debarker. A conveyor moves the shipment toward the debarker, then drops a single log in front of it onto spinning rollers. The rollers rotate the log, while the debarker makes its way from one end to the other. It chews off the bark with its sharp, toothed blades. What the debarker shaves off is put to good use. The bark gets processed into gardening mulch, and they burn the sawdust in the wood-fired boiler that runs another part of the plant. Next, one log at a time drops into a mobile carriage that runs it through a circular saw. The carriage has sensors which detect the log's extremities and report its dimensions to a console located in the operator's cab. The operator interprets the data. Using a joystick controller, he flips the log into whichever position maximizes the yield. The first few runs trim off the rough surface and square the shape. The next runs cut boards, which the sawmill sells to flooring plants. This continues until the log is the exact dimensions of the bridge tie. Again, nothing is wasted. The sawmill processes the cutoffs into wood chips, which it then sells to companies that make particle board, strand board, and similar construction materials. The sawmill stacks the ties for transfer to the bridge mill next door. The role of the bridge mill is to frame the bridge, also known as dapping. That's the process of making the specific holes and notches in each tie for attaching it to the steel beam on which it will sit. At the bridge mill, the bridge layout supervisor processes one tie at a time. He carefully reviews the engineer's blueprints, which assign a number to each and every tie. These numbers specify precisely where the saw has to cut notches and where the drill has to bore holes. The locations of these notches and holes vary depending on the tie's position on the bridge, so he must follow the blueprints meticulously. After measuring and marking it all out, he sends the tie to the dap saw. The operator sets up each cut, lining up the mark with laser lights, which indicate the location and the cutting depth of the blade. The notches are just the right size to fit over the steel beam on which the tie will lie. Next, a worker using a drill press bores holes for hook bolts, which go through the tie to secure it onto the steel beams. Each tie receives a metal identification tag, which includes the bridge and tie numbers. On each end, workers nail on a mesh plate made of rust-proof galvanized steel. The plate has teeth designed to grasp and hold together the wood fiber to prevent the end from splitting. After nailing the ID tag to one of the end plates, workers force in both plates with a press. The tie's last stop is the adjacent treatment plant. They spend 24 hours inside a high-temperature, high-pressure chamber which penetrates them with a creosote borate solution. This protects the wood from rot and insect damage and extends the tie's lifespan from about a decade to at least 25 years.